So I do apologize about that. So this is going to be part two, same day, because unfortunately there's no easy way for me to cut these videos together. So it's going to be part one. This is part two. I paused. I thought I paused the video. I must have hit stop when I was trying to go back and check the spelling of this. But we have our trigonal planar, and if we, like I said before, here I have x, x, x. And this pair of electrons are pushing off this one. This one's pushing off this one. This one's pushing off this one. So they want to be as far as possible away from each other. And it's kind of, excuse my terrible writing, kind of looks like a circle. So if we remember how many degrees are in a circle, there's 360. So if I divide that by 3, I come up with 120 degrees for my circle. And lastly, we have four atoms around my central atom. So I have my 1, 2, 3, and 4. Now here's the thing, is that at a certain point, because we are dealing with 3D shapes, it's not, they can't get far enough away from each other on the same plane. So they're going to start creating that more of a 3D shape. One's going to be kind of pushed towards us off the plane of the paper, and one's going to be pushed behind the plane of the paper. So how I represent, so items that are on the same plane of the paper are going to be just my single lines, but when they are pushed towards me, the readers are being pushed off the plane of the paper, it's actually coming out towards us, then that's going to be this filled in triangle. That represents it's coming towards me, the reader. Now, how do I get the one that's going away from me? That's where I see the dotted lines here, the dashed lines. And that means it's going behind the paper itself. There's 4 items. So if we think of 4, we may think of tetra. So here we're going to give it the name tetrahedral. And it's going to have the bond angle of 109.5 degrees. So, lastly, before we get into the homework, I want you to do a little more practice. So I want you to draw the Lewis structures of our breathable oxygen, nitrate, and also our CF4. So draw the structure, and then over here, I want you to tell me which of the 3 shapes did we see. Is it going to be, excuse me, is it going to be linear? Is it going to be trigonal planar? Is it going to be tetrahedral? So I want you to take a second. I want you to do that. And when I unpause this video, I'm going to jump to it. So let me hit pause in 3, 2, 1. Okay, so here are my shapes here. I see my oxygen. We've already done this one, so it'd be pretty. If you did it from scratch, hey, that's good one for you. It's great practice. What's my shape going to be? It's going to be linear. Here, excuse my extra throwing there, but I have NO2. I forgot to add the -1, or else the electron number doesn't quite make sense for the octet rule. But if we add that extra 1, because nitrogen has 5 valence electron, oxygen has 6. So if it's 5 plus 12 is 17, so we need that extra 1 there. So please make sure you put that there. And I do apologize for not putting that earlier. That means that I should have 4 dots between one end and one of my oxygens, and that looks to be a straight line, so that's linear as well. And lastly, CF4, I'm working with 32 dots, so if my fluorines get all the dots, I see off my central carbon, gives me a tetrahedral structure. Now, I need you to take a look at your homework from last time. So I asked you guys for the homework that I want you to go back, so do questions 1 through 20, odds only. Odds only. Just for right now. You're going to go back, and it's going to give you some more practice for you to do on your own. But for right now, I just want you to do the odds only. And here we have all the different Lewis structures. Now, what I want you to do for each of them is I want you to come up and tell me, is it linear? Is it the trigonal planar? Or is it the tetrahedral, the tetrahedral base shape? That's what I want you to do. So if I'm looking at number 1 here, number 1, I see my central carbon. There's 1, 2, 3, 4. So if I treat that as A, 1, 2, 3, 4 X's around my central atom, that means that there's 4. That means I'm going to write beside it tetrahedral. If I'm looking at number 11 here, I see, don't know what, oh, that's the I. That's the I, not another set of lone pairs. I'm like, wait a minute, it doesn't look right. But here, I see silicon oxide, I see everybody's in a straight line, so I'm going to label that as linear. I want you to take this time, I want you to identify your 8 other molecules that you did, Lewis structures. I want you to determine their base shape. Is it the linear? Is it the trigonal planar? Is it tetrahedral? I'm going to hit the pause button in 3 seconds. I'm going to let you try that. And when I unpause it, I'm going to have all of them done so you have a chance to check it. And then we'll talk to you about your homework. So taking a look here. So number 1, we have a tetrahedral. Number 3 are 2 chlorines. That's going to be a linear shape. Number 5 here, CHI3, 1, 2, 3, 4. So it'll be tetrahedral. Number 7, we have a straight line. So it's going to be, oh, I almost forgot. I do apologize. So this one isn't tetrahedral, linear. It's actually tetrahedral. Why? Because you have a pair of lone pairs here and there. So that makes it tetrahedral, not linear. Oh, sorry. That also is the same thing for number 3. I apologize about that one. That one was a mistake on me. Because, again, I have those electrons there. When there's no electrons there, that's when it's not linear. That's when it is tetrahedral. Here it's linear because we have the shared electrons. There's no extra set of electrons floating up top of it. These are going to form bonds. So that's why this is linear and this is tetrahedral. Let's go to the next page. Tetrahedral. Here again, so looking at number 17, straight line, so linear. Number 3, so I'm looking at this right here. So 1, 2, 3 items. That's where it's going to be the trigonal planar. Now, when I see you guys in person, we're going to walk through this again. We're going to help clarify any types of misconceptions of anything that's going on. But I do want to point 2 things. I have 2 other spots for practice for you. You have the next page that you can go through. Now, you may notice that a couple of these are actually repeats from the homework itself. So it gives you a chance to practice redoing the shape. Best way to determine the base shape of something is to first draw the Lewis diagram, the Lewis dot structure. Because like where I was making mistakes, if you're just speed running it like I was, you're going to make mistakes where it goes, oh hey, I totally did not account for those extra electrons that were above and below the central atom. So that's going to make things problematic for us. Like I did. I just made that same mistake because I didn't think about it before I started running through things. But what you are going to make sure you're going to have is you want to make sure you have this molecular shape lab. Now, this is the lab I talked to you guys about last time where it's going to take several days to complete. So we have an introduction. I'd ask you to read the introduction and also to answer the pre-lab questions. Because what you are going to complete for homework for today is that you're going to answer your pre-lab questions and you're also going to do Part 1. Notice that the several pages have it broken up into Part 1, Part 2, Part 3. I also have a detail of the different parts on the second page. So we have the procedure. Only complete parts assigned by your teacher. Please do not work ahead as you may miss important points and it will make the learning part difficult. So for part 1, for 2 pages, you're going to draw the dot diagram and you're going to identify the base shape of your molecules. Complete the pre-lab questions on the attached table. Complete all dot diagram Lewis structures for the listed compounds and put them in the column titled Lewis dot diagram. These must be done before you proceed with the rest of the lab, and then you want to predict the base shape. Some of these you've already done. We just did CF4. We had done a couple other ones from before. I'm digging around, but you want to do just these 2 columns because it says part 1, right? Part 1. So you're going to do the Lewis dot and you give it the base name for each of these guys. Just 2 pages. I know too, we just did that one as well. So I want you to work through these and just determine the base diagram. Oh, you can't see it. The Lewis dot diagram and also the base name and the drawing. So I'm asking you for like the A and the X structures that we did on the previous one. So this is what I want you to do. I want you to take this drawing and I want you to put that here in your base shape for the name and the drawing. So you're going to get the name, drawing, name, drawing, name, drawing, name, drawing, name, drawing, and you're going to draw the structure. Now, I do understand that these are very small boxes, so if you want to do them on a separate page at first, and then you want to give me the final product over here, that's fine, but make sure you have both. Make sure you turn in both, because part 1 is a homework grade, but part 2 and 3 are going to be added up together. So this is going to be worth 4 points. Like all of our homework grades are always 4 points, but part 2 and 3 together are going to be worth 100 points. So here's the thing, is that you can't do part 2 and part 3 without doing part 1. The math won't math for you if you don't do part 1 now, so you can get the full points in part 2, part 3. So that's where I'm going to stop for today. So be sure, if you need any help, please send me an email, as I might be out the next couple days. I could find you some resources if we're a little confused. But I want to make sure that you are in a good place, and I want to make sure that you get this part 1 done before we move on to part 2. Alright gang, well that's it for me. Have yourself a great day, and if I don't see you next class, hopefully I'll see you in the one after. Alright, bye now.